We've got some really great questions already. We'll try and get to as many as we can. If not, we'll ask the panelists to stay a little bit during the break and just answer ones directed at you that we couldn't get to. So I will turn it over to Adam from Contra Costa County to moderate.
Thanks, Emily. And thanks to all the speakers. That was a wealth of information and truly fascinating. I'm just trying to get up to speed on embodied carbon in general, so definitely be going back through your slides. So yeah, we'll get into the questions. First one is for Wes. Are EPDs widely available, or is CalGreen's intent to increase market demand for producers to make EPDs commonplace?
Yeah, thanks, Patrick, for the question. EPDs are becoming widely available, I would say, and it depends on the product category, the product type. Some have stronger market signals or regulations that have required them to create EPDs. So you're seeing a lot of EPDs for things like concrete, steel, there's increasing pressure to get wood EPDs that are product specific. I think the intent is, CalGreen is not necessarily intending to be the one that makes those changes. I think other regulations like CARB is working on will require more EPDs from manufacturers. And then the voluntary programs like LEED, we've been doing EPDs in the LEED rating system for 13 or 14 years now. And at first there was very few EPDs. There was just a handful. And now there's tens of thousands. I've seen upwards of 100,000 on some estimates of EPDs. Now, those aren't all in California, of course, but they are in the US and North America. So there's a lot of local government leadership on that. There was some federal government leadership. We'll see where that goes. But the intent is to get more EPDs so that we can start making better decisions. I don't think EPDs are the end result that we want. We want lower carbon materials, and EPDs are kind of the avenue to get there. But I'll ask other speakers if you have another answer to that as well.
And if not, we can move on to the next question.
I'll just add, I guess that, I think we've come a long way in availability of EPDs for structure and enclosure materials and even interiors, but we still have some major gaps in the
So next question's for Matt. Does specifying climate-friendly refrigerants reduce embodied or operational carbon?
So that is a good point, and it depends on how you account for it. So within LCA and the different life cycle stages, so refrigerant leakage would be reported within life cycle stage B1, which is an in-use phase accounting for fugitive emissions during the lifespan or life cycle of the building. So any impacts from refrigerant leakage would be reported within that life cycle stage. A lot of the time, that is not a required life cycle stage for typical whole building life cycle assessment reporting and regulations. However, with that, there is environmental impacts with the production of some of these refrigerants, as well as the disposal of these refrigerants. So you'd have a little bit of a combination of A1 to A5 from the production and then installation of the refrigerants into the systems, B1 from the refrigerant leakage during the lifespan of the building, as well as some end-of-life emissions from disposal of the refrigerant at the end of life of the system.
Interesting. And then just a quick follow-up. Are the climate-friendly refrigerants generally higher carbon or require more carbon or result in more carbon to produce, or?
A lot of the time they don't, and the trade-off between the refrigerant leakage impacts and the upfront impacts is like so skewed that if it leads to a slightly higher upfront environmental impact of producing the refrigerant, that trade-off with reduced refrigerant leakage emissions in B1, because it would occur over the entire lifespan of the buildings, is largely outweighed. So a lot of the time you're really only focusing on the environmental impacts associated with refrigerant leakage or emitting the refrigerant to the atmosphere.
Thank you. Okay, we'll move on to another one for Christine. How do bio-based materials compare on characteristics such as durability and lifespan, and fireproofing? Are there current available products on the market that are comparable to conventional ones?
Yeah, that's a great question. I would say it depends. There's quite a wide variety of bio-based materials you could be talking about, and I think it also depends on the application and conditions that the materials will be subject to where you're thinking of using them. We have been doing some work recently on incorporating more bio-based materials into conventional buildings, and fire is definitely a consideration. So we do have to be careful about finding those appropriate applications. So maybe not all bio-based materials are a good fit in particularly fire-prone locations. But I think there's also ways to kind of address or mitigate some of those concerns as well with treatments and/or using kind of a combination of materials to reduce the risk.
And yeah, recently on the news I saw a report of a mycelium-based 300-unit affordable housing project in Oakland. So I'm wondering, do you think they took steps to fireproof the mycelium for that, or is that kind of, or you know anything about it? You can touch on.
I don't know much about that project specifically, but yeah, likely. I mean, I think probably to get code approvals, they would, likely have to show that they're, using this material in a way that's safe. So,
Okay.
yeah.
I would add
All
that
right.
there are insulation materials used in Europe and elsewhere. There's one that's wood fiber that they use for insulation. And so they have been able to prove that there's, by adding, borates or something as a fire retardant, that they can meet those fire codes. So there's a solution to those, and hopefully they're not super toxic or anything, but it's not a new debate. We've had cellulose insulation here in our buildings for many, many years, and that's newspaper used as insulation. And without, I don't think, much issue with meeting fire code on those. So it's not something I think that, as long as they're meeting all the appropriate codes and standards, should be acceptable. No, anyway, code officials might disagree on the call, but that, I think a manufacturer would say that they're meeting all the applicable regulations for fire safety in those products.
You. Let's see. Next question, another one for Christine. This was asked in the chat actually. And apologies if you did touch on it. I don't think you did, but can you touch on Rockwool insulation, on the Rockwool insulation carbon payback?
Yeah, I think this was a question about one of the graphs I showed in the presentation. And which is a good call out that maybe some of the colors and the graphs are too similar. But is it possible to pull that back up, or maybe I could just talk about
Yeah,
it generally?
possibly. Whoever's controlling the slides, is that possible?
Yeah, we'll work on that, but one moment.
Okay. Well, in the meantime, I'll just say, so I think what we see in that graph is that the XPS insulation types are the ones where the whole life carbon starts going back up after a certain point where you see that inflection point. So there's a yellow XPS insulation shown in the graph, and then also a lighter yellow for the Rockwool. So that's one of the ones where we see, Rockwool is one of the ones where we see it kind of flatten out over time, because it is a lower embodied carbon compared to some of the plastic-based insulations that have a gas blowing agent that is used to create those kind of bubbles in the plastic that give it that good insulating value. And I think the worst offenders on the graph are older types of XPS that use high GWP blowing agents. I think there's been some improvements with newer versions of those products with lower GWP blowing agents, but they still are kind of at the higher end of the embodied carbon spectrum.
Then just a quick clarification for me. When you say blowing agents, is that's something that's being mixed with the insulation and then blown onto or into the space, or
yeah, so it's added during the manufacturing process. Basically the gas is kind of blown into the plastic, which I think is in a liquid form initially and then solidifies during manufacturing. So it's those gas bubbles trapped in the insulation that, you know, give it a very high R value per inch. But as the insulation breaks down over time, some of that gas gets released, which is why it has high embodied carbon.
so thank you. All right. So I think that covers that question. We'll move on. This one's for Matt. How do you prevent places for refrigerants to leak in MEP design?
That is an interesting one. So some of it is all tied together, and refrigerant leakage typically occurs at like junctions or where there's connections. And a lot of that is site-made connections. So if you can reduce and simplify layout geometry of your system, basically don't have super complicated elbows, connections, angles, and everything like that, that is a good way of mitigating some of the refrigerant leakage, as well as having due diligence and a good reporting practice and QA system during construction to make sure all of the joints and connections in your system are well sealed, to basically prevent any area where that refrigerant can leak.
The less joints and connections in general, the less leakage.
Yeah, exactly. Okay. Yeah, and then also with that, a lot of the time, site made or like shop fabricated systems have a lot like more control in the QA process for fabrications. So a lot of the site or shop made fabricated connections don't have as much refrigerant leakage risk as the ones made on site.
Interesting. All right, we'll go to another one. And this one's actually for all of you. What challenges do you anticipate jurisdictions and designers encountering while implementing the new embodied carbon requirements?
I could start with that, I guess. And I think Greg Mahoney's question in the chat about reference standards and tying to that and using some of these standards as a number for reduction, you know. Anyway, we're in the early stages of, I think, understanding embodied carbon at a regulatory level for buildings like this. I think the science is very clear, as was shared with some of the slides, that embodied carbon is a major contributor to greenhouse gases globally, and locally it's a big source of them. So I think the decision to kind of regulate around embodied carbon has been happening at the local level and at other scales too. But I think that when it comes to project-specific application and doing a whole building LCA or collecting EPDs, or as Matt was sharing, you know, getting those, looking into MEP and things, we're still at kind of the, I wouldn't say the beginning, but we're still early in that curve of adoption as a practice. And so I think this is an evolution where the design professions, the contractors, everyone needs to start using embodied carbon and these terms as part of our as part of literacy for the building industry, just like we are with energy efficiency now. Pretty much everyone can talk about an insulated window or a better insulated water heater right on a project. We need to have that same type of understanding and analysis for embodied carbon. So I think the way things stand, the challenge is that you may run into places where you're the first one as say a city or an implementer, you're the first one telling somebody they need to think about their embodied carbon. And so that education hurdle can be big. There's also lots of tools out there, and I put some in the chat or in the question Q and answer, but some are hard to work with, or they're still cumbersome. So there's just a bunch of kind of getting up to speed that we need. and that's going to take some time. Wonder if others would share. Yeah, Matt.
Yeah, just building off of what Wes said, I think two of the key things is communication. Like from the onset of the design process or even before the design process and then planning and implementation, just talking about it, asking the right questions, and getting that discussion going can do a lot for getting everyone on board, having that collaborative mindset that there isn't a one size fits all solution. And what works for one building doesn't necessarily work for all buildings or your building in particular. So just because something worked in the past doesn't necessarily mean it will work in the future, but having those conversations and discussions from the onset of implementation and practice is key for helping transition everyone's mindset, because you don't necessarily need to know how to do a full scale assessment, or you don't need to know all the calculations, but you can do a lot for getting that low impact design philosophy and implementation philosophy in just by having those conversations right from the start.
Yeah, definitely. Oh, go ahead.
Go ahead.
I was going to say, I totally agree with that sentiment. And I think it's not just kind of owner and design team too that need to be talking about this from day one, but the sooner you can get the contractor involved as well, makes a huge difference.
And I was to say, I hate to cut this short because there's still so many good questions, but we are out of time. So thank you all for this first panel, for giving us a really great education on embodied carbon and operational carbon and its trade-offs. There are some questions we didn't get to in the chat. If you guys wouldn't mind maybe looking at ones that you feel comfortable answering, so that those folks can get their questions answered during the break. And we will come back at 10:35, everyone, to start the second panel. Thank you.
Thank you.